vanishes. Welcome to the Mirrored Flask with TNT demonstration videos. First, we are going to add 10 milliliters of the 0.25 moles of dextrose solution into the flask.
Now let's eyeball. Do we want to get a funnel?
Next, pour 30 milliliters of the silver nitrate solution, AgNO3, into a beaker like so. Now while stirring in the beaker, you need to add the concentrated ammonium hydroxide, which is NH4OH, the 3 milliliters of it, with your eyedropper into the solution while stirring.
You have to be patient when you do this, and if it works, you won't see it happening. Then all of a sudden it'll start to get darker, darker, and darker, and then all of a sudden it'll be opaque. And it seems to be working because it looks like it's already turning.
Yeah. Ta-da! Mirrored flask.
TNT Labs, here again to explain a mirrored flask. We made a solution of silver nitrate and ammonium hydroxide, and this solution is actually called Tollens reagent. It is used to prove that there is an aldehyde. Use the sugar as a reducing sugar, the dextrose, and with the silver acting as an oxidizer, it oxidized the anhydride right here of the dextrose, and it created the carboxylate ion right here. And simultaneously, it created silver, metallic elemental silver, unlike the aqueous silver we used in the silver diamine ion. And we swirled the flask, and as we swirled, the reaction occurred, and it deposited the participate silver, and it coated the inside of the flask, causing a mirror to form.
What do we got on our plate today, Zach?
Well, today we'll be serving up a heaping helping of club soda, if you know what I'm saying.
I know what you're saying. This dish is called Quick Freeze.
Quick freeze!
Gotcha!
Oh,
You're so funny, Zach.
Yeah, you're funny, Mariah. Oh, gosh.
Alright.
Alright.
So, as seen earlier, we showed you how club soda could just freeze like that.
Instantaneous.
Well, what happens is when you mix a solute with a solvent, it decreases the freezing point of the solution.
Right.
So let's apply this to what we did today.
Well, today,
we had water as our solvent,
and rock salt as our solute in the ice bath,
as well as carbon dioxide as a solute in the club soda.
Right.
So as we said earlier, when you mix those, it decreases the freezing point of the solution. So let's give an example. How about, some winter weather?
In Wisconsin.
Yeah, salt on ice.
Ice on the roads.
It's not good.
You have to get to school safe. I mean,
Gotta keep those kids in the school bus safe.
the school bus. You gotta think about the school bus.
So what happens is, your big salt truck comes by, puts the salt on the ice, and the ice melts. How's that work?
How's it happen? Well, like we were saying earlier, the salt
Is our solute.
is the solute, and it mixes with the ice on the roads.
And since the solute lowers the freezing point of the solution, we've got the salt on the ice, which melts the ice because the salt is increasing the freezing temperature of the ice, so now it doesn't freeze.
Causing the ice to melt on the roads.
It doesn't freeze anymore at 32 degrees.
Right.
Let's say 18.
Yeah, so, I mean, you got a few degrees to work with.
Helps
You're all
out
good.
with those buses. So let's see how this worked in our experiment.
In our experiment, let's apply this.
Well, the soda was in the salt bath, right? And that was keeping the liquid of the soda from freezing. And so was the carbon dioxide in the soda.
Right.
So if you take the soda out of the salt,
And
you open
twist off the cap
of the soda, then some of that carbon dioxide is released,
causing the concentration of the carbon dioxide in the soda to drop.
so what's keeping it from staying a liquid?
Nothing.
What happens?
It freezes instantaneously. Or as we say, quick freeze.
Right before your eyes.